Okay, so in the last video we discussed about active class coverage, and we also talked about three special cases, which were the general active class coverage, the restricted active class coverage, and the correlated active class coverage. And the main idea was that in active class coverage, the major or the active clause do affect the predicate. But in this video, I am going to discuss about another very interesting class coverage criteria, which is based on the fact of inactive clauses, and in this case, we consider those clauses which we also call the inactive clauses or the minor clauses, and we talk about those combination of values in which the active clauses do not affect the predicate. So in active class coverage, we discussed about those clauses which affect the predicate, but in this scenario we are going to discuss about those cases in which active clauses are not going to affect the predicate. So in active class coverage is based on the fact that the active clauses do not affect the predicate. However, in the case of active class coverage, we have seen the definitions and examples where we discuss that active clauses do affect the predicates. Active clauses are also called the major clauses in the predicate. Inactive clause coverage takes the opposite approach, and here major clauses or the active clauses do not affect the predicate. So here is the first definition, which is inactive clause coverage, also abbreviated as ICC. And here we say that for each P, which is a predicate in the set of predicates P, and each major clause CI in the set of clauses CP, choose minor clauses CJ, and again the same condition that the major and minor clauses are not going to be the same. And we will look at those tuples in the truth table where the CI or the major clause is not determining the predicate P. And further, there are 4 requirements for each major clause. First one is CI evaluates to true with the predicate true, then CI evaluates to false with the predicate true, then CI evaluates to true with the predicate false, and then CI evaluates to false with the predicate false. So we consider both cases when the predicate is true and when the predicate is false, and for each of these scenarios we also look at the major clause, whether it's taking values from true to false or not. If these 4 possibilities happen, then we will say that this is inactive clause coverage criteria has been fulfilled by that particular predicate. So unlike active clause coverage, the notion of correlation is not relevant, because we discuss this possibility that when the minor clauses can actually make the predicate true from one scenario when the active clause was true and when it was false, and then the changing of values was allowed in the correlated active clause coverage. But in this case, since major clause is not determining the value of predicate, so the correlation is not actually possible. But since we are talking about the predicate values, we also consider the true case and we also consider the false case. Therefore, we can always achieve predicate coverage when we are talking about inactive clause coverage. Now we discuss the special case of the general inactive clause coverage. As we had the general active clause coverage, similarly we have the general inactive clause coverage, and it is abbreviated as GICC or GICC. And the first 3 lines are the same for each predicate in the set of predicates P, and each major clause in the predicate in the set of clauses CP, choose minor clauses such that J is not equal to I, and CJ are the minor clauses, CI is the major clause, so both cannot be the same. And the next condition imposes that CI does not determine P. So we have to look at those possible values where changing the value of the major clause does not actually change the value of the predicate, and the values chosen for the minor clauses CJ do not need to be the same. Similarly, we will look at those values where Cj does not necessarily have the same values. They can be the same and they can be different. So the same fact is expressed mathematically here. Here you can see that if Ci is true and when Ci is false, both the value of Cj in both the scenarios are equal, and for all Cj, or, and there is the possibility that either this fact is true or the fact after the R is true, where when the major class value changes from true to false and the minor class value in both the scenarios is not equal for all Cj, it means the minor class values can have the same value or they can have the different values. So now we have a very simple example to illustrate the concept we studied on the previous slide. We have this very simple predicate of consisting of three clauses, A and B or C, and I have drawn the truth table here also. You can see there are the 8 rows and the predicate is true only in the first 3 rows, and in the remaining 5 rows it is not true. So we have to look at those possibilities where, for example, if I am considering A as the major class, if I am considering A as the major class, then I have to see whether A is true. I have to look at those rows where A is true and where A is false, and the first possibility is that I have to consider the predicate also, when the predicate is true and when the predicate is false. So in these 3 rows the predicate is true. So if I find A's values to be true and false here, then I will fulfill the first condition, that for the predicate true, A's value is true and A's value is false. So it means the first condition cannot be fulfilled in this case, because A does not have a false value where the predicate itself is true. And in the same way, we can also consider those rows where the predicate is false and A's values changes from true to false. For example, the predicate is false here in these 2 rows, and A's value is changing from true to false in this case. So we can look at such cases where A's value changes from true to false and the predicate values remains the same. It remains like false. Okay, so here is the worked out solution for this predicate. If A is our major class, so there are no feasible pairs where the predicate is true and A's value changes from true to false, as we just illustrated a short while ago. And when the predicate's value is false, it is false in these rows, and we can look at where A's value changes from true to false. Actually, in general case, we can have several possibilities: 4, 5, 4, 6, 4, 7, and 4, 8. Here we have listed one example, that 4, 8 is the possible possibilities that we can actually fulfill the second condition of general inactive clause coverage. And then is if we want to make B as a major class, so then I will be considering this column, and I have to look at values of B when the predicate is true. So the predicate is true here. So are there any values where B changes from true to false? Yes, in row number 1 and in row number 3, B's value changes from true to false and the predicate remains true. So that is just listed here, that in this case the predicate is true and the major class in this case is B. Its value changes from true to false and the predicate's value does not change. Similarly, you can also think about the false cases here, and now I am considering this B column, B's values, and I have to look at those tuples where, for example, B's value changes from true to false. So for example, I can look at row number 5 and row number 7. Here the predicate is false in both these rows and B's value has changed from true to false. In the same way, you can also think about 5 and 8. In the case of 5 and 8, the minor class values have changed, but B has changed from true to false and the predicate didn't change. So in the same way, you can compute other values which achieve general inactive clause coverage. And remember that general inactive clause coverage, minor clauses may be the same or they can be different. So we consider both the possibilities in the case of B and A also. So the next definition is of restricted inactive clause coverage. It is denoted as RICC, RICC, and first three lines again are the same. For each predicate in the set of predicates P and each major clause Ci in the set of clauses P, choose minor clauses Cj. J is not equal to I, meaning that the minor and the major clauses cannot be the same. And next condition imposed is that Ci does not determine P, means we have to look at those tuples in the truth table where the value of Ci changes from true to false, but the predicate value does not change. And the second condition imposes the values chosen for the minor clauses Cj must be the same. It means now we have a restricted choice that we will just be using those values of minor clauses which are the same in the case when the major clause was true and the major clause was false, but the predicate value does not change when the major clause value changes from true to false. The same condition of the minor clauses is mentioned in mathematically. Cj Ci is equal to true is equal to Cj Ci equal to false, meaning that when major clause value changes from true to false, the value of minor clause remains the same, and this will be true for all minor clauses. Now let's have a look on an example. So this is the same predicate which we worked out last time, and there are the predicate is A and B or C. The first three rows in the first three rows the predicate has value true, and in the last five rows the predicate has value false. And now again we have to look at those rows. For example, if A is being considered as the major clause, then we have to look at those rows where predicate is true and A's value changes from true to false. So in the first three rows, A does not change from true to false, and these are the only place in the truth table where the predicate is true. It means the first possibility cannot be achieved again in this case. When the predicate is true, A does not change from true to false. The second possibility is whether A changes from true to false when the predicate is false. So predicate's value is false in the last five rows of the truth table, and here you can see that A's value is true in this part of the table. And the second condition imposed in the case of restricted inactive clause coverage was that the minor clause values, which are B and C, they must be the same. So the only possibility can be this, that A's value for A as major clause, B and C have the same false values, and A changes from true to false, and the predicate does not change in the case of false. So one possibility for A to achieve inactive clause coverage when the predicate remains false is 4 and 8. So that is listed here. So in the same way we can work out other possibilities. So here you can just see that in the case of A, there are no feasible pairs when the predicate is true, that is A does not change values from true to false when the predicate value is true, and when the predicate is false, A's value changes from true to false in rows 4 and rows 8, only with minor clause value fixed as false. And in the same way, if we want to make B as the major clause, then we will have to look at this column. Then the predicate is true in the first three rows, and we have to look at those values where B changes from true to false and the predicate remains the same. And then you also have to see whether the minor clause values remain the same. Yes, they remain the same, they are true in rows 1 and 3. Therefore you can pick this pair for this possibility that the predicate is true and the minor clause values remain the same and the predicate does not change from true, but the major clause value changes from true to false. In the same way, you can look at the 5 rows where the predicate is false. Now I have to look for those rows where B's value changes from true to false. For example, it is true in row number 5 and it is again true in row number 7, and you can see that minor clause values are F and T and the predicate didn't change. Therefore I can pick this pair for fulfilling this possibility that that can achieve a case of restricted inactive clause coverage in this case. Likewise, you can also look at row number 6 and 8. Here these value changes from true to false, and minor clause values remain the same, they did not change, and the predicate value also didn't change, it remained false. So 6-8 pair is also mentioned here, that it can be used as a possibility to cover the second case where the predicate is false for B as active clause. Similarly, you can work out for C as major clause. So in this video we looked at the possibility of inactive clause coverage, and inactive clause coverage works by assuming that major clauses do not affect the predicate. So we looked at those tuples in the truth table where changing the value of the major clause didn't affect the value of the predicate, and we also considered two other criteria: general inactive clause coverage, which allowed that the minor clause values can be different or they can be the same. However, there was a strict restriction in the case of restricted inactive clause coverage, that minor clause values are not allowed to be different. And since major clause value is not affecting the value of the predicate, so therefore the notion of correlation is not relevant here, and correlated inactive clause coverage is therefore not possible in the case of inactive clause coverage criteria. And the last point was predicate coverage is always guaranteed, because we are considering when the predicate is true and when the predicate is false. Therefore, when we achieve either of these general inactive clause coverage or the restricted inactive clause coverage, we also achieve predicate coverage. So that is all for today's video. In the next video, I will be talking about how we can use a definitional approach to find active clauses in a predicate by setting some values of other minor clauses, which will make a specific clause active in the whole predicate. Thank you very much.